Hello, everyone, and welcome for another edition of our AMP Calgary chapter webinar program. I'm your host, Brett Jonathan. So for those of us in Calgary, we get to look outside our windows at another reminder that spring doesn't officially start in April, no matter how nice and warm March seems to be. So today I have the privilege to welcome Brian Cheshire to our webinar program. Brian is a 19 veteran in the coatings industry with time spent at several national coating manufacturers. He's an AMP senior certified coating inspector and is heavily involved with AMP within the committees and the local chapters. In addition to these affiliations, he's also a member of the American Waterworks Association, the National Rural Water Association, the Water Environment Federation, the International Concrete Repair Institution, as well as the American Concrete Institution. As a market manager for water and wastewater at Carbonation, Mr. Cheshire guides the overall market strategy for the company in this key market. In addition to that, he helps lead the Carbonation program, which aims to educate, connect, support, and engage young professionals interested in the coatings and corrosion industry. So we also have AMP Calgary chapter's own vice chair and support, Ravi Nagarajan. Ravi is Carboline's business development manager for Western Canada. He has 24 years experience in the protective coatings industry, spanning various roles, including technical sales support and inspection. He's an AMP certified coatings inspector and an AMP instructor, teaching CIP courses all around the world. Guys, it is fantastic to have you both come join us today. Thank you so much.
Yeah, thank you for having us.
That's awesome. So, so Brian, what are you gonna be talking to us today here about?
Well, first off, I do have to say, don't be mad at me, but it's 80 degrees where I am now, and it's not a cloud in the sky. So I hear that's a little different from where you are maybe right now.
Oh yeah, dumping buckets of snow. It's in the wonderful spring storm around here. Lovely. Happens every April.
But no, today we're going to talk about really a hot button issue that's on a lot of people's mind, and that's talking about the infrastructure, the crumbling infrastructure. Really, the focus today is going to be on water and wastewater infrastructure, with a heavy emphasis on the wastewater side because it, quite frankly, is so corrosive. So we're going to talk about that. We're going to talk about really how we got to this point. Then we're going to talk about some of the various forms of corrosion that you're going to find in a water or wastewater system. Then we're going to dive into some of the specific substrates within these structures and talk about some of the surface prep and coating considerations for these. And then lastly, we're going to kind of take a 30,000-foot view and look at some different protective coating and lining types.
Awesome. Well, that sounds pretty fantastic. I'm looking forward to it. So before we jump into that there, I'd like to take a moment to recognize some of our annual sponsors. Honestly, nothing of what AMP Calgary would be able to do without our continued support from those annual sponsors who are able to provide this webinar series to our membership at no charge. So today, I'd like to highlight one of our gold sponsors, OnStream. So OnStream Pipeline Inspection helps gets you the complete picture on pipeline defects. You know, just like you need red, green, and blue to see a picture in full color, MFL inspection requires axial, radial, and circumferential signal vectors to be captured by the iLight tool. OnStream's ultra-high resolution tri-stream MFL uses triaxial MFL technology to measure all three vectors, resulting in higher quality, more accurate data than traditional MFL tools. Visit onstream-pipeline.com for more information on how OnStream's advanced tools and algorithm technology helps reduce unnecessary digs and cost. And of course, to all our annual sponsors are a huge reason why we can do what we do. Our sponsors help fund several initiatives AMP Calgary takes on to promote the knowledge of corrosion, sustainability, and asset integrity to our industry and the next generation of engineers. To each one of our sponsors, we sincerely thank you for your continued support. So if you haven't had the chance yet to check out our YouTube channel, please go to our website at nacecalgary.ca, and from there you can find a direct link to the channel with our past presentations. Yes, we're still primarily using that domain until we get our new domain up and running with the AMP name on it, but rest assured, nacecalgary.ca will always take you where you want to go. So Brian's going to give this presentation live. Be sure to stick around after the presentation, and then we'll move into a live Q&A session. Submit your questions in your Zoom client by clicking that little QA button on the screen at the bottom there. If you're joining us from YouTube Live, enter your questions into the comments there and I'll be sure to ask it. So without further ado, Brian, go ahead, share your screen and take it away.
Well, once again, thank you for that kind introduction. You already stole our thunder there, so I'll won't put you through our bios again, nor will I put you through really the itinerary for today. We'll just go ahead and, for sake of time, jump straight into it. So I would say, or I would venture to say, that almost everyone on this webinar today has probably seen the data or has heard the reports about the current state of the water wastewater infrastructure in the United States. If you look at our infrastructure here in our collection systems, many of the manholes are beyond their expected design life. The fact is that there's approximately about 4 million manholes here in the US that are greater than 50 years old. Inflow and infiltration is a big issue in a lot of these systems. Quite frankly, a lot of that enters in through a manhole. And what happens is the treatment plants get overburdened with all of this extra inflow and infiltration. You'll often see manholes called the low-hanging fruit of infrastructure rehab. Part of that is because of their accessibility, but I would say mostly it's due to the fact that about half of a system, of a wastewater system's I&I, enters in through a manhole. So talking about treatment plants here in the US, we've got roughly 16,000 or so publicly owned wastewater treatment plants. Scary part is it's estimated that about 81% of these are operating at their design capacity. And the even scarier part is about 15% of those have reached or exceeded those design capacities. So many of you, being members of NACE and being involved in the industry, you've probably seen a lot of the reports on the direct cost of corrosion. There was a report that came out in 2002. It was a joint report from NACE and the Federal Highway Administration. In 2002, they estimated that direct cost of corrosion to be roughly $276 billion. Some of the latest numbers on that, 2013, it was upgraded to, or downgraded, depending on how you look at it, but to $476 billion. But I would be scared to see what that cost might be today, given the inflation that we're currently experiencing. So when you look at that cost of corrosion, if you look at it specifically in the drinking water systems and sewage systems, that number is estimated to be just south of $80 billion. The good news with that, or I guess the silver lining, is that really a good portion of that cost can be saved by implementing some of the known corrosion mitigation techniques that we employ, with protective coatings being one of those, which will be really the main topic of our presentation today. So here in the States, every 4 years, the American Society of Civil Engineers puts out an infrastructure report card. And so the latest version of this was in 2021. When you look at the wastewater infrastructure, it received a grade of D+, and then our drinking water received a grade of C-, which was actually, I believe, a little bit of an upgrade. So at the time when this came out, Pete Buttigieg was fairly new in his role, but he had the quote of saying that the report card is a warning and a call to action. And I can tell you from the news cycle now, with the American Rescue Plan Act and with the bipartisan infrastructure bill that got recently passed, I would say that they're finally starting to do something about it here. So moving on from the US, but speaking specifically to Canada. So how does Canada stack up when it comes to the water and wastewater infrastructure? So to help answer that question, I referenced the Canadian infrastructure report card. And the latest version of that I was able to locate was 2019. But if you look at this, it actually rates potable water systems, wastewater systems, and stormwater systems. So we'll be talking today for a minute about potable water and then wastewater. But if you look at the potable water infrastructure assets that were included in this survey, they break it out with between linear, the linear portion of these drinking water systems, which are going to be your local water, transmission, distribution pipes. And then your nonlinear assets are going to be your drinking water treatment facilities, your pump stations, and then your reservoirs. And so if you look at that category, kind of the scary part is approximately 25% of the potable water infrastructure was found to be in either fair, poor, or very poor condition. So if you look at the wastewater side, it's not much better. The wastewater infrastructure assets that they included broke it out pretty, very similar. Linear wastewater assets included your sewer pipes and your sanitary force mains. Your nonlinear assets included your treatment plants, your pump stations, lift stations, and even some of the storage tanks. So the findings of that, roughly 20 to 30% of the wastewater infrastructure was found to be in fair, poor, or very poor condition. So I would say a lot of the issues that we're facing here in the States are really not much different north of our border here. So when we talk about corrosion, it's important really to talk about corrosion specifically in water, wastewater, and really, how did we get to where we are today? So, the fact is the waste stream has become more aggressive in nature over time. It was fairly common 30 years ago to find hydrogen sulfide concentrations around 10 to 15 parts per million. However, with such things as the Clean Water Act, which eliminated heavy metals from the waste stream, we've seen those numbers, I would say, increase exponentially, and has in turn caused a lot more corrosion. There's some other things that have kind of led to this. One of the major shifts was a move to larger regional treatment plants instead of having smaller treatment plants in each community. The fact is, a lot of these developments, it's a nuisance. They don't want to have a wastewater treatment plant near them. So we started seeing more of a shift to these regional plants. But with that, the sewage had to go further distance. So you had longer transport times. And then you also had longer detention times, which in turn allowed the waste stream to become more septic and in turn more aggressive. So the fact is, and this will be the common theme we'll talk about today, but corrosion control in the wastewater infrastructure is imperative, because some of these areas of the system can definitely get very aggressive and can break down a structure very quickly. So it's my understanding that we also have some potable water or drinking water personnel on the phone today. So I wanted to make sure that we talked about corrosion in potable water. So speaking specifically to water tanks, that there's really some common types of corrosion that we see. The fact is, in steel tanks, steel in and of itself is very irregular in its composition. So what you end up with are some areas that on that same steel plate, some areas may act as the anode and others may act as the cathode. And so if you don't properly mitigate this, if you don't put a barrier coating on it, if you don't employ cathodic protection, and some of the other known techniques that we have available to us, the result ends up being corrosion attack that really ends up appearing as random, I would say closely spaced pits. Another thing that we see in water tanks is steel that's under stress can be anodic to unstressed steel. So some of these stresses can be caused by welding or through the bending or forming process. I would say in my time in the field, a very common form of corrosion that I've personally observed is dissimilar metal corrosion. So as you know, putting on your NACE hat, talking about the galvanic series and talking about different metals, you know that different metals in contact with each other will establish a corrosion cell, which can see which will see corrosion occur at the more active metal. So you may see this in a tank at weld seams with fasteners and with any other attachments. So on this slide, the last thing I wanted to point out is another form of corrosion, which is coating pinhole corrosion. For coatings projects, you know, it's vital that you have a holiday-free film, because what ends up happening in immersion is corrosion activity is going to concentrate at those holidays in the coatings. And so if you're an asset owner or engineer, I would say it's vital that you put some means in your specification and some measures for holiday detection. So as you know, it's very vital to have a corrosion control plan in place if you're an asset owner. You know, knowing what we know about corrosion and its effects, you know, it really highlights the need for one of these corrosion control plans, you know, especially for assets in water and wastewater exposure. You know, there's some benefits of a corrosion control plan in place. And as I've listed here at the top, you know, you've got cost savings over time. You've got public safety contributions there. You know, that there's also some key elements that we have listed here that should be considered. First of which is proper design is one thing that can be employed. Understanding the different service environments is also very vital. You know, we touched briefly on corrosion in the systems, and we're gonna dive in here in a minute into some of these corrosion mechanisms in a little greater detail. But just knowing what your substrate and what your structure is going to have to hold up to is vital. You know, cathodic protection may be used in conjunction with a coating system. You know, protective coatings and linings do a great job. You know, give great barrier protection. And we'll talk about some of those different coating and lining types later in the presentation. But as you know, it's much more cost effective to be proactive with your corrosion control plan rather than reactive. And you can see the figures here at the bottom that were mentioned, but you think at times it's common sense, but it's one of those things that, you know, the can gets kicked down the road, and before you know it, the investment has grown exponentially. So now that we've talked about really just a high level overview, we'll dive a little deeper into corrosion in wastewater environments. So here's some of the common corrosion mechanisms that we see in municipal wastewater systems. We won't touch on all of these, but we'll touch on a few of these in a little greater detail. So the first of these, and I would say probably one of the more heavily researched and reported corrosion mechanisms in wastewater, is what we call biogenic sulfide corrosion. And really, this is driven by the activity of bacteria that's going to be present in some of these conditions. So I won't go through all the steps here, but note that this is a process that happens in stages. The end result is really the item of concern here. What you end up with is sulfur oxidizing bacteria that end up consuming hydrogen sulfide, and they end up excreting or discharging sulfuric acid. And so this sulfuric acid, it's actually been measured at a pH of less than 2. But the highly alkaline cement paste in the concrete matrix is very susceptible to attack from that low pH acid. And so if you're not paying attention, or if this goes undetected, you know, I've seen this cause concrete degradation up to 2 inches a year. So it can be catastrophic. And it's one of those things with underground assets and maybe assets that you're not looking at all the time, it can act very quickly. But you're going to find this in various parts of the system, but really the main areas that you'll see it in are in the head spaces of structures within the collection system, you're going to see it in transmission pipelines. As I mentioned a minute ago, talking about those longer transport times, talking about the waste stream growing septic. You are going to have some attack in some of those situations. And then also in the initial stages of treatment at the wastewater treatment plant. So headworks, preliminary treatment, even primary treatment. So here's a good illustration really of how this process takes place. So one thing to really note here is that a lot of the degradation happens both in the slime layers and then also above the waterline in the vapor spaces, as you can see listed here at the top of the diagram. So here is a beautiful real life picture of some of the damage that can be done as a result of this biogenic sulfide corrosion. And so take note again that really a lot of the degradation in some of these structures is going to happen up in the vapor spaces. So I can honestly say I would not want to climb down into this one. I may not live to tell about it. And here's, unfortunately, and this is when it hits the news at this point. If left undetected over time, here's what can happen. And once again, it's one of those things that's out of sight, out of mind. So if you're not keeping an eye on your assets and you're not employing some corrosion control techniques and some methods, this can be the unfortunate side effect of that. So another form of corrosion that we see in wastewater environments that's worth mentioning is carbonation of concrete. So what happens here is carbonic acid can be derived in a few ways. First, from atmospheric carbon dioxide in water, but this also can happen below the waterline in some structures where you see dissolved carbon dioxide evolve as that carbonic acid. And so by nature, this is generally a slower degradation, but there are some factors that can accelerate it, that we have listed here. So, the permeability of the concrete, higher temperatures, even higher relative humidity numbers there can speed this up. But I've seen this really scattered throughout a treatment plant, but probably the areas that are the most prevalent are going to be in your primary and your secondary treatment structures, with aeration basins really being one of those where I see this fairly frequently. So the next form of wastewater corrosion that we want to talk about is chloride-induced corrosion of rebar in the concrete. And so, as you know, and as you've studied concrete and concrete design, you know that it's generally is going to be low in tensile strength. And so typically it's going to be reinforced with steel rebar in order to account for that. What ends up happening in some of these concrete structures, if they're not protected, is you end up getting chloride ions that are going to permeate to that, basically to that rebar. And initially that rebar is actually going to be pacified or passivated by the alkaline concrete around it. But if that concrete doesn't have barrier protection, or you don't have cathodic protection employed, or you can end up having those chloride ions permeate that surface. And what happens is they end up getting to the steel rebar. And as you can see diagrammed here, over time, it's going to cause that steel rebar to corrode. Concrete, because it is low in tensile strength, as that rebar expands with corrosion products, it's going to end up causing cracking, spalling, and in some cases, complete failure. So this is one of those things that can be prevented with some of our known corrosion mitigation techniques, with protective coatings being a great choice there to help provide that barrier protection. But you're going to see this in various areas, but where I've observed it, you see it a lot in secondary treatment, and then also in your final treatment, or what's known as tertiary treatment. So structures like a chlorine contact chamber is where I've seen this happen a decent amount over time. So, but before we move to the next section, it's worth mentioning there are some other abrasive forces and physical forces that need to be accounted for in wastewater structures. Freeze thaw damage, abrasion, erosion, cavitation. Especially when you get into the headworks facilities, grit chambers. I mean, some of these physical forces can be very significant. So while we won't talk about these really in great detail today, I did think they were worth mentioning because these are things that need to be accounted for and need to be protected against. So before moving to the next section, I always like to show this picture. This was a real life scenario. This was taken in the field. A much younger Brian was calling on a wastewater treatment plant in a very rural part of the state here, and stumbled upon this structure when I was doing an evaluation. And unfortunately, this was one of those things that could have been prevented over time, but the owner had when this structure had been built, I would venture to say had probably value engineered out the coating or lining and opted not to line it. And over time, you can see that the degradation was probably pretty slow here, but they've let it get to the point of almost no return. So I always like to show this as a good illustration of really what can happen if you quote unquote kick that can down the road and don't address some of the issues on the front end. So now that we've talked about really a high level view of corrosion in the system and talked about some of these corrosion mechanisms, I'd like to dive in for a minute and talk about some of the commonly seen substrates that will need to be coated in water and wastewater environments. So this discussion on substrates and wastewater exposures is going to logically begin with concrete. It's estimated that about 80 to 85% of the substrates in wastewater environments are concrete substrates. I mean, the fact is it's the most widely used construction material really across most all industries, but you can really say that for the water wastewater market. So concrete's used really in various structures all throughout the system. You see it all throughout the collection system. You see it all through a wastewater treatment plant. Concrete in these environments, you're going to be exposed to atmospheric corrosion, but then also you're going to have many of those corrosive forces that we just mentioned in immersion service within these structures. So, as we've alluded to, concrete really can see various corrosion effects, including biogenic sulfide corrosion, where that Portland cement is attacked. And like I mentioned, if left undetected, that can be very, very catastrophic in some cases. We also see, acid attack by sulfates. I mentioned carbonation as well as the physical forces. So before coating concrete, it's important first to properly clean and prepare the surface. So a great reference standard for that, many of you have probably reviewed and gone through and know the ins and outs of, but Sspc SP13 Nsf is probably the most commonly specified concrete standard that I see out there. There's currently some debate whether it's a standard or a guide, but I'll leave that for another day and another discussion. But this is a good guide because it does give some inspection procedures prior to surface preparation, and then it also really lays out some of the different methods of surface cleaning, and then it talks about some of the different methods of surface preparation. I thought it was worth mentioning here some of the newer standards that you see, the Sspc CAB or concrete abrasive blasting standards. There's actually 3 levels of that, and these are written specifically to preparing concrete surfaces that will end up receiving a lining system in most cases. So there's also, when you're building a specification or reviewing a specification, There's also several ASTM standards that speak specifically to concrete prep, which are listed here. But the one I wanted to focus on here is the ICRI standard, the 310.2R, which does a great job of laying out the various concrete surface profiles, or CSPs as we refer to them. But these are going to be called out typically before you apply any resurfacer, coating, or lining. So here's a good visualization here of these different CSP levels. Naturally, as your films get thicker, a greater CSP is generally going to be called out, and there's different means and methods to get to the different levels of concrete surface profile. But most any product that's going to be sold for concrete substrates is going to, on that data sheet of that product, it's going to have a CSP level called out. And so if not, it's something that needs to be clarified, because this is very important, because much like with steel, there is a big difference in performance with the lining system. And a lot of that's going to be dependent on the surface prep. So making sure that you have the proper surface prep conducted first, and having that proper profile first is going to be very important. So some other things to consider with concrete, first is the fact concrete is very porous. And a lot of times that's caused by the air voids in the concrete. Another thing to look at, and something that sometimes gets left out, is looking at the pH of concrete. So, the pH of new concrete is going to be roughly 12 to 13, but to coat concrete, you really need that pH to be 9 or above. And there's some methods out there to test for pH, but note that really anything below that 9 or 10 pH is going to denote that there is some kind of contaminant there, or that there's been a prior chemical attack. And whatever it is that's going on there, it needs to be addressed prior to applying a coating to that surface. There's also several defects in concrete with finishing that need to be prepared and need to be removed and filled. One of these, this picture here on the right, is latents. This is in essence a weak unreacted layer of paste that's left on the surface. And over time, that's going to end up releasing from the surface. And I've seen quite a few times through the years where the contractor did not remove that latents, and in turn coated over the top of it. And then over time ended up having issues, and that coating system did not last like it should have. So talking about the methods, so now that we've kind of covered some of the considerations with the concrete substrate itself, really the question is, how do we get there? And I would say probably one of the most effective means for preparing concrete surfaces to be lined is abrasive blasting. And so, we alluded to that there's several standards out there that really lay out some of these guidelines, but and then there's also some wet abrasive blasting methods that can help suppress dust as well that we see used fairly often. But all in all, I would say this is probably one of the most effective means of preparing a concrete surface, especially for a thick film liner. So once we prepare the surface, another thing that unfortunately gets forgotten about sometimes is resurfacing. There's several different ways to get there, several different types of products you may see out there. There's a lot of cementitious goods, there's straight epoxies, and then you also see epoxy mortars used. But this is a vital step, talking about outgassing and pinholing and achieving the proper service life. I would say a lot of that is very dependent on surface prep and then proper resurfacing. So here's some real life examples here of some structures that had a coating system specified. But as you can see here, there's quite a bit of work that needs to be done prior to even thinking about lining these structures, because Without a resurfacer here, you're asking for outgassing issues, pinholing issues, and probably several others. So when talking about coatings for concrete specifically, there's several considerations. I mean, and there's many more than these, but these are just a few of the things that you may need to consider. First off, is this going to be immersion service or is it going to be atmospheric service? Those forms of corrosion can be very different from each other. So it's important to know what kind of service it's going into. And then speaking of service environment, let's just talk about a wastewater treatment plant. It's important to note, is this concrete substrate going to be in the headworks or is it going to be in a final treatment structure? The fact is, the headworks is going to be more abrasive, more aggressive. So you're probably going to need a more robust material in that area. We alluded to a minute ago, some of the repairs and some of the resurfacing that may be needed. That's something to consider when coating concrete. And then there's also, some of the physical properties that you may need to consider. And with the structure itself, is there cracks that need to be bridged? Do you need flexibility in the lining system? Does the lining need to have low permeability? There's really a lot of things that you need to ask here. And I know as on the coating side, these are questions that we asked often just to make sure that we're recommending the right material and that we're helping you optimize the life of that asset. So another common substrate you're going to see in these environments is steel. The fact is, steel is the most commonly used metal in construction, because because of its cost, quite frankly, and its availability. Ironically, though, it corrodes at the highest rate when you compare it to a lot of the other metals that are used in construction. So within wastewater specifically, you're going to see steel used in various immersion and in atmospheric exposures. And because of its nature to corrode, protective coatings are needed to protect steel in these various forms of corrosion. So like with concrete, surface preparation is going to be vital here. The surface preparation of steel, including its cleanliness, really should match both the service conditions as well as the intended service life of the coating system. So if you're in immersion service, surface prep's going to be typically Sspc, SP10 near white. We sometimes see SP5 called out in some cases, some extreme cases. For atmospheric exposure, SP6 is going to be preferred, a commercial blast, but there may be situations where a hand tool, power tool clean may be the only thing that's possible. Blasting may not be feasible for what it is. The plant may be in operation. It may disturb too much if you end up bringing a blasting operation in. So knowing the difference there between the levels of surface prep and making sure that matches the service is very important. So another substrate worth mentioning, and actually where I reside is the capital of the world for ductile iron. Kind of a little fact there, but ductile iron is one of those substrates that is often misunderstood, and a lot of times you see specifications trying to get contractors to treat it like steel. But I would say that would be, first and foremost, knowing how to prepare these surfaces is going to be vital, but because it is different than steel. But in general, ductile iron has very high tensile strength. It's very durable. So you see it used a lot in with pipe fittings and immersion, buried, or even atmospheric exposure. You do see corrosion with it if left unprotected. If it's in corrosive soils or in sewer pipe, biogenic sulfide corrosion, and then I would say other really abrasive or physical forces can also wear it down over time. But as I mentioned, it's when looking at ductile iron and when thinking about coating or lining it, it's not like steel. So the proper surface preparation standard that you should be looking at here is NAPF 500. So, and note within that standard, there's differences in how to address the interior as well as the outside. And I would say another important thing to note is when you see a piece of or stick of ductile iron pipe on a job, if not specified any differently, a lot of times you're going to see an asphaltic coating on the outside of ductile iron. That's standard issue for a lot of these manufacturers. And the problem is you can't really coat over that asphaltic layer. So it's important on a job, if it is going to receive a high performance coating, to make sure that it comes without that asphaltic layer on it. Within a plant or within the infrastructure, you're going to see other substrates. We won't really dive into these in any greater detail today, but note that there may be instances where you need to coat galvanized steel, where you may need extra UV protection for PVC, stainless steel, aluminum. Maybe these are in very, very aggressive areas that you need that duplex or that dual protection there. So I would say with these, refer to the manufacturer and just make sure that the proper surface prep is being employed for these, because sometimes these aren't the easiest to coat, but just kind of knowing how to address these is very important. So I would say definitely consult your specification and your manufacturers there. So the last thing we'll touch on today, it's kind of that 30,000 foot view of some of the different coatings and linings that are used in water and wastewater environments. And this is just a good illustration here. Really the way we break these out, as I alluded to earlier, we look at coatings for atmospheric protection, and then we also look at coatings and linings for immersion service. So there's multiple technologies out there. There's multiple products out there that can address these different services. And that's where, people like Ravi and myself, we're asking a lot of those questions on the front end when we're helping someone design a specification, just to make sure that we're specifying the right material for whatever that service exposure is. So first, when you're talking about atmospheric coatings, there's some different considerations here. You may be concerned with aesthetics, with having a material that has very high color and gloss retention. You may be looking at a material that has great weatherability. Some other things to consider is if you're in a plant, the criticality of that structure. Is this something that can't be down long? If that's the case, then you might need something that cures quickly or returns to service quickly, or is maybe even a little more surface tolerant than some other materials. There's regulatory needs. There's certain parts of our country and parts of the world where VOCs are a major concern. So knowing what the local VOC restrictions are is very important. And then I would say one thing that's often forgotten about is the maintainability of that atmospheric coating system. If a plant has the proper corrosion control plan in place, they're going to probably be maintaining that system over time. So they may opt for something that is easier to repair, easier to touch up over time. So when you look at coating types for exterior atmospheric protection, there's some different categories that you see listed there. Zinc rich coatings, we see these used often as a prime coat on the exterior of steel substrates. These materials are going to provide great galvanic protection. I would say of these, epoxies are really the workhorse material. One limitation of them, though, is their poor color and gloss retention. So that's really where your polyurethanes, polysiloxanes, and your fluorourethanes come in. And of those, polysiloxanes and fluorourethanes are going to be your higher cost materials. However, they're going to give you the longest service life and the longest color and gloss retention. And then, before moving on, acrylics are worth mentioning. We do see those used in some maintenance scenarios and then also in some overcoat situations. And so shifting gears here and kind of the last few points we'll make here. When you're looking at immersion service, you can really break it out between wastewater immersion service and then potable water immersion service. These have some different considerations there that we have listed here. We've touched on a lot of these on the wastewater side, but I would say primarily being able to match the lining type with the exposure is going to be the most important here. In those more aggressive areas, having coatings and linings that have hydrogen sulfide resistance and low permeability is going to be some of the most important factors there. And then when you look at the potable water side, naturally, it first and foremost needs to be Nsf 61 certified. This can be a whole nother webinar in and of itself, and this is a talk that I give quite a bit, but the new companion standard Nsf 600 that's taking effect at the 1st of 2023, that's any material that's going to be used in contact with potable water has to comply with it. So that's going to shift some of the specifications that we see out there moving forward. But then also, if you're looking at some of the different inside coating systems for a water tank, you may have instances where you need something that returns to service very quickly. You may need something that has high film build in a single coat, or you may even need something that can cure in lower temperature, such as polyurethane technologies. So we won't touch on all these, but I did want to point out really the two main products that we see in immersion service. First of those being epoxies. These are really the workhorse of lining materials. They're going to protect or give you good barrier protection really against a lot of various elements. Generally speaking, they have great, they have good chemical resistance, good water resistance. The application of these, you've got some flexibility there. These can be applied in some cases by brush and roller or by single leg airless spray. Some formulations even you can add a mortar blend to and trowel on. So, and I would say probably the majority of epoxy linings we see used in the space now, most all of them are going to be high solids or even 100% solids. And so talking about Nsf 600, you're going to see a greater shift to these types of materials for that as well. Just real quick, some of the disadvantages, some of these epoxies can blush, they chalk when exposed to UV exposure, very little elongation. So if you have a structure that may have some movement or where you may need a little crack bridging, something like a polyurethane may be a better choice there. Here's just a few examples of some epoxy lining applications. And here, as I mentioned a minute ago, would be a epoxy fortified mortar. And so I know aromatic polyurethane linings, these are materials that have been used in Canada for quite some time, have some definite benefits. Just note when I talk polyurethane, I guess in this context, we're talking aromatic, not aliphatic. Aliphatic is going to be your atmospheric exposure. Aromatic is going to be typically your linings. And so I alluded to that these have higher elongation. These can be applied in extremely high film builds, can be turned back to service very quickly. In some cases, 2 to 4 hours. They've got great physical characteristics to them. I mean, they're abrasion resistant, they're damage resistant. And I would say very important for your climate is that they're can cure down at lower temperatures. But some of the things to consider that they often require plural component spray and will require DH in a lot of cases because they are very sensitive to moisture. And kind of going back to surface preparation, they have marginal adhesion. So your surface prep has got to be really good with these types of materials. And here's just a few examples of some applications of aromatic polyurethanes. So you can see they've got some good overall flexibility in where they can be used. But we see them used really both in water and in wastewater. So just kind of some final points before we go to Q&A. I do want to point out that, talking about a corrosion control plan, this is something, if you're an asset owner or an engineer assisting an asset owner, very important to have one of these in place because it really can extend the life of a lot of these key assets. Knowing the different types of corrosion that's present and how to protect against these forces is very important. Knowing the different substrates that you're going to run into and knowing how to properly prepare those and how they differ from each other is very important. And I would say, when looking at protective coatings and lining materials, really note that there's no one coating or lining that does it all. There's not really a one size fits all. So that's a lot of tools in the toolbox, and there may be instances where we use one over another, but definitely important to kind of lay out all those considerations on the front end. So before closing, I did want to highlight some of the references here and thank the people involved here with some of the research that went into this. So I'll give credit where credit's due there. And Brett, I guess with that said, I'll turn it back to you to facilitate the Q&A. But if any of you have any questions, feel free to reach out to Ravi or myself. I've listed both of our contact information here on the screen.
Oh, that's awesome, Brian. No, thank you very much for putting that together. What a fantastic presentation. I know myself, I learned an absolute ton with that, and yeah, especially coming from an oil and gas industry, it's certainly a very different perspective of what you're managing and the different kinds of threats. So I really appreciate that. So, to everybody here, please, I know we have a short time here for Q&A left on it. So if please enter your questions to the Q&A panel here on Zoom, and I'll try and ask it here on here. But maybe to kick things off here, so when you're having concrete actually in service, how do you inspect it to see what the corrosion is doing and if the coating is actually performing to what you want? Do you have to take the whole structure completely out of service, especially if it's an immersion type, or do you have other methods on there to be able to estimate that kind of degradation?
Yes, I would say, first and foremost, you want to look at what's above the water line, and a lot of times you can see some of the issues happening there, such as carbonation and other forms of attack. But it's not a bad idea over time to, and granted, it may not be feasible in some areas, but it's not a bad idea to look at the structure in its totality, because there may be some things that are happening below the water line that you don't know about. But I know there's a lot of good guides out there that really talks about some of the things to look for. I know Ravi, you could probably mention a few, but I know Sspc SP13 is one that does a good job of laying out some of those inspection methods and really some of the things to look for. But I would say, looking for degradation, really checking the pH of the surface. Some of those things are very important and can sometimes cue you in if there's something happening.
No, thanks for that insight. That's a good perspective on that. Maybe that kind of ties into a little bit to my next question though. So you mentioned before about how, owners on themselves should have like a corrosion control plan. how can coating manufacturers be a part of that? Can they? What can they do?
Yeah, so and Ravi chime in on this too, but I know personally in my career, one of the things that I've been able to do to help some of the municipalities in my locale was offering to come in and do a very objective third party condition assessment and really looking at, doing a survey of their facility basically, and looking at a lot of the structures and factoring in multiple things, but really kind of giving them that information at the end that they can turn into action basically. Because I know I had a facility that they didn't know where to begin, and they had a lot of money that had gotten infused into the facility, and they didn't really know how to spend it best. And so we came in and did a very objective condition assessment and really pointed out the areas to them that, hey, if I'm spending that money, this is probably where I'm going to put it first.
Yeah, to add what you said, Brian, the condition assessment is the primary factor. So whenever the asset is down or they are taking the areas for maintenance and stuff, that's the time that you have to go and do either on the concrete side or on the steel side if you are doing it. So just want to add something on the previous question that you were talking about on the identifying how it is done. That's one area of people doing it, but now I've seen like a lot of new technologies coming in where you can send a robot inside the water and then you can go and take a lot of pictures and inspections. So people can do it without even taking the asset down, whether you need an conditional assessment. So you have any other questions coming on, Brett?
Does that technology also work in wastewater pipelines as well?
Yeah, it does. Yes.
Oh, really?
People started putting this into the all industries where you can go down. It was used in marine. It started all with marine, and now it's been brought into other industries as well. Yes, very much.
Mm-hmm.
Cool. So, obviously with concrete being quite a porous structure with lots of potentially, different like rocks and grains and stuff within it, how do you, when you put a coating on it, how do you check to make sure the whole coating is holiday free?
Yeah, you want to take that? Yeah, go ahead, Bobby.
Yeah, I'll just wear my instructor cap here, of course. So yeah, concrete, it's done the same way with a high voltage inspection because concrete is conductive. By and large, it has got moisture in the substrate. So we do the holiday free based on the coating resistivity, and once the lining is applied and sufficiently cured enough, you can go and connect to the high voltage holiday inspection depending upon the coating thickness. Either you do high voltage or low voltage. So it finds the holidays and then finds the defects for people to do the repairs then and there before putting back into service.
And Robbie, I'll add kind of the challenge with that sometimes can be finding that ground. Do you have something to ground it to? That's what I see kind of as a challenge sometimes, but
it does. A lot of techniques have come in on that part of the instruments that the instrument manufacturers. Either you can forcefully put an holiday into the coating nail, ground a nail, or put a wet surface finding somewhere, and then you go back and repair it. Yeah, techniques are there to fix those.
Like how small can it detect even like a small holiday that's maybe on an edge of like a surface of maybe like a few millimeters by a few millimeters, or does that only detect large holidays in your coating?
No, even small holidays, yes, it is detectable.
Wow.
So,
yeah, even stuff that you may not visually see, it'll pick them up.
Well, I mean, that's got to be the challenge with concrete, because I mean, when you're dealing with metal surfaces, most of it's smooth, right? Concrete, especially some of those pictures you showed, not a single bit of that concrete was smooth in a lot of cases. So that's got to be a huge challenge in coating application with that. So speaking on coating structures on it as well. So when you build a concrete structure for service, can you put it in a service uncoated and then maybe address it later, or are there some challenges with doing that?
So unfortunately, that's a trend we see a lot. When a job gets that dreaded term value engineered. When a project is value engineered, the coating a lot of times may get cut. The unfortunate side effect of that is like that picture I showed from that rural wastewater treatment plant. That was probably something that they had long ago decided, like, we don't need to coat this aeration basin. We'll just leave it as is. And over time, that slow degradation got to the point where, I mean, it was to the point where they were debating on, do we resurface and coat this, or do we just tear this sucker down and build a new one? So I always advocate for coating it on the front end, not to sell more material, but just to help extend that life, because it can get away from you quickly. But Robbie, did you have anything to add to that, or?
Oh yeah, again, like if you see the cost of maintenance and going and rehabilitation on that is going to be a very expensive process, whereas while the asset is being built, it is still easy, and the tradesmen and other thing, people are on the site. Before even they sign off, you can get those things asset protected. So that gives you the life extension. You just only have to go back and do the maintenance on those, like any automobile that we are doing. You buy a new car, and progressively you maintain it for it to run for a long days. So same system applies to coatings.
Good analogy there.
Awesome. No, I appreciate that. So we're getting up here just a little past 1 o'clock. I'll ask just one last question here before we wrap things up. So Brian, I mean, you went through several different slides on here talking about the different types of coating and where it can be used. Obviously, there's I think you said it well, no one coating can be good for all applications. So how does one pick the right coating for specific application? What techniques or tricks do they use to use?
No, Brett, I appreciate that. That's a great question. And, that's something we get asked a lot. And quite frankly, if I wasn't in the field, let's say I was an engineer or owner, and I'm looking at 6 different products that have been proposed, I'm going to have a hard time, because all I have is marketing material in front of me. So how do I know which one is the right one or the best one? And so one of the things I always advocate for is case histories. Does that product have a proven performance in that same exposure on that substrate? Ideally, if you can find a case history in a similar environment even. But that's one mean, and I would say another one is looking at relevant performance testing. There's some good ASTM tests out there that can show, accelerated corrosion, and really allow you to not necessarily evaluate side by side, but at least gives you a good idea of, hey, is this the right material for this exposure? But Robbie, did you have anything to add to that, or?
Oh, you covered it, but it's besides all those things, it's always to call, if you have 3 or 4 recommended product lists, call each manufacturer representatives, and they can help out. Or a lot of experienced consultants in the field who have been working on this area for many years, so they'll be able to help them out in the selection process. Yeah, case histories are the greatest reference, and especially in the infrastructure market, people have their own associations, and then they keep on talking, chatting and exchanging informations as well. That will be a good biggest platform to get these updates.
No, well, fair enough. We definitely appreciate it. From oil and gas, we obviously do it very similar on that, where we talk, about different case histories, and then, learn from failures and issues that happened in the past and what's worked and not worked within the industry as well. So no, fair enough. So no, thank you both very much for your time. Brian, that was a fantastic presentation. We're going to have to wrap things up here. So I appreciate you joining. It was a great Q&A session. Some good participation with that. So, yeah, with that, we'll close things down for the day. For those viewers still left here, we do have some upcoming presentations coming in May. So please follow us on LinkedIn and join our email web list, emailing list to get notifications when those registrations are coming live. So thank you again. Everybody have a great weekend, and we'll see you next time. Take care. Bye.